Now, I would like to invite Dr. TA Piyasiri to commence the second session. Over to you, sir.
Thank you very much. We have been active session in the morning and a very good discussion time. And now we will focus on the second session, which I see as operational applied research work done by several officers from the Navy. And 4 presentations, and the same rules will apply. We have 10 minutes time for submission. And also the questions can be posted in the chat box or can be orally asked at the end of the presentations. So with that, let us start the second session. And I wish to invite and introduce the first speaker, the development of a robust fireboat operate at Fishery Harbours. The presenting author is Lieutenant Commander PMKC Chandimal. Lieutenant Commander Engineering PMKC Chandimal has graduated from Sir John Kothalaula Defence University.
Good morning, ladies and gentlemen. I will be delivering a presentation on development of a robust fireboat to operate at Fishery Harbours. The sequence of my presentation has flashed on the screen. Introduction. Sri Lanka consists with 23 fishery harbours, and every fishery harbour secured minimum 20 to 30 fishing boats. However, there is no any reliable system to extinguish a fire if it occurred on board a fishing craft. The only available method is seeking assistance from the Municipal Council or from the Sri Lanka Navy. Within that period of time, fire has converted to a major fire and it spreads to neighboring fishing boats due to the windy condition in coastal areas. It has created a devastated damage to the rest of the secure fishing boats in harbour. The recent fire incidents occurred at Fishery Harbours as shown on the screen. The picture shows the fire occurred at the Galle Fishery Harbour. Department of Fisheries and Aquatic Resources and Ceylon Fisheries Harbours Corporation still did not have a viable solution to counter fire incidents on board fishing craft. Director General Manager, Harbour Operations reveals that non-availability of sufficient capacities of portable fire extinguishers to extinguish the fire is one of the main problems. Sri Lanka Navy has identified the necessity of a floating platform to hook and tow out the fire craft from the fleet of fishing craft and to carry out the fire extinguishing process in a close quarter periphery in the bay. Inshore petrol craft has the ability to operate in shallow waters ineffectively and propelled with 250 horsepower 4 OBMs and can achieve the speed of 25 knots. To ensure craft survive and keep floating, moving and fighting, it is highly essential to lay emphasis on fire prevention, keep extinguishing and protection with optimum operational at all times. Therefore, it has been identified the requirement to have meticulous floating firefighting platform for efficient management of firefighting operations on board fishing craft at harbours. The research problem statement of study is non-availability of suitable floating platform in close quarter to extinguish fire occurred on board fishing craft secured at fishery harbours. The scope of the study is to develop an inshore petrol craft with a designed major firefighting system which is suited to throw water flow to extinguish the fire occurred on board fishing craft located at fishery harbours in Sri Lanka. Methodology. Inshore petrol craft is developed with a major firefighting system on board to assist the fishing craft secured at harbour in an emergency situation of fire. Main firefighting system on board a small craft is designed in par with the international and the local regulatory requirements, and following standards were adhered. Merchant Shipping Act and the Lloyd's Register we have adhered. During the design of inshore petrol craft, length and breadth of the craft, fabricating material, forward and aft draft of the craft, speed, and the propulsion system were mainly considered. The specifications of the inshore petrol craft are flashed on the screen. Design parameters. Exact location identified to have the sea chest without obstructing the stream water flow for the hull. Following design parameters were considered to maintain the minimum distance of 20 meters in between two craft and to throw the water column with required volumetric flow and pressure. System head curve plotted considering the pump head and the flow rate. Pump selection did with matching the pump head curve and the system head curve. Selection of system operating point is done using National Fire Protection Association standard for installation of fire pumps. The indicated charts show the head and power changes of the fire pump. We have selected the fire pump as per the head and the fire power. Right-in arm curve or the GZ curve. Location designed to install the diesel fire pump and its effect for the longitudinal center of gravity due to the weight factor of the pump. The stability calculations were carried out and found the stability variations of the craft. The displacement of the IPC is 9 tons and the GZ for the inshore petrol craft is shown on the screen according to the angle of heel. The material selection has been carried out in par with the small craft code 12.6.7 and marine quality pipes were selected as per the laid down pipe schedule. Discharge in the water has been arranged through a 50 mm branch pipe consisting with jet and spray nozzle. Branch pipe is installed on the strengthened mount with a rotation of 120 degrees. Therefore, single line fireman system designed to install onboard fireboard to extinguish a fire once occurred in fishing craft at harbors. Pressure head and flow rate of the pump. The discharge velocity of the flow and the volumetric flow rate is calculated. Consider the minimum distance of 20 meters in between two craft, the output pressure and the flow rate is calculated. The pressure head is 80 meters and the flow rate is 244 gallons per minute. Therefore, it has been analyzed the condition with the performance curves of the pump head curve, power curve and efficiency curve and selected the pump with a pressure head of 80 meters with flow rate of 250 gallons per minute to cater the minimum requirement. As per the Merchant Shipping Act for small craft code 4.10.1, marine quality steel and the seawater suction line outer diameter selected. According to the pipeline schedule, the associated two valves also matched with the steel. A 65 mm diameter jet and spray branch pipe was installed at the mount with the purpose of maintaining the distance in between the craft during the fire extinguishing operation. Stability of the craft. Stability of the craft calculated changing the pump location at the forecastle area of the craft. The aft of the craft is not considered for the pump locating to get the maximum advantage while engaged with the fire. Pump bed designed after calculating the stability of the craft and changes of longitudinal center of gravity and vertical center of gravity. The changes of vertical center of gravity is 0.2 meters and it is a positive value. Therefore, vertical center of gravity increases. Further change in longitudinal center of gravity is 0.01 meter and stability remains as previous. The comparison of right-in arm curves are shown on the screen. Conclusion. The fires on board fishing craft at Fishery Harbours was an unsolved problem since last 2 decades. However, all of them were failed to provide a lasting sustainable solution. The development of an inshore petrol craft with a designed major firefighting system which is suited to throw the water flow to a minimum distance of 20 meters to extinguish the fire occurred on board fishing craft. It will fulfill the requirement of a viable fire extinguishing method on board fishing craft at harbours in Sri Lanka. Therefore, floating platform as inshore petrol craft is essential at present to extinguish a fire once occurred on board fishing craft and to prevent and spread of fire to neighboring fishing craft. Thank you.
Thank you. The presenting author is Commodore MCP Dissanayake. And since there may be new participants in this second session, I will introduce Commodore Dasanayaka formally. Commodore MCP Dissanayake, Chartered Engineer India, is currently performing as the Head of Department of Marine Engineering and holds 2 patents for his research papers published so far. He is an inventor and has published 6 publications on brackish water reverse osmosis application, fan boat building, and oscillation water column, ocean wave energy converter. He was the Director in Research and Development at Sri Lanka Navy and has received commendations on several occasions from the Commander of the Navy and His Excellency the President of Sri Lanka for his innovation. Further, he was awarded the prestigious Japanese Sri Lanka Technical Award for his own developed low-cost reverse osmosis plant to eliminate chronic kidney disease from Sri Lanka. Moreover, he has vast exposure to marine diesel engines and possesses a master's degree in engineering from the University of Tasmania, Australia. Over to Commodore Dasanayake for your presentation.
Good morning, ladies and gentlemen. Today I am going to discuss develop an explosive laden unmanned waterborne vehicle to eliminate Liberation Tamil Tiger Elam or LTTE suicide boat attacks at sea. My outline is as follows. Whose Liberation Tamil Tiger Elam or LTTE, how Sri Lanka Navy encountered enemy attacks at sea, design features, material selection, design of hull, propulsion system, control system, test method, results and conclusion. LTTE was one of the most ruthless terrorists, which consist of operational sea capabilities. In the early 1980s, LTTE has formed a naval wing called Sea Tigers. Subsequently, the Sea Tiger leader was introduced an elite and highly trained suicide cadres to this special element to carry out attacks against Sri Lanka Navy by explosive laden boats. Initially, SLN was suffered heavily. Further, the SLN fleet was upgraded by Supreme boats with new technologies. Though it was not enough to evade the LTTE suicide boat attacks, and SLN was losing their boats during sea battles against the enemy. Sea Tiger attack plans. While the Sri Lanka Navy vessels moving from Trincomalee to KK's harbour, what happens? The moving as a fleet unit. Then by the time LTTE were in Chale and Mulativ, they were attacking through their attack boats and suicide boats. In this picture, you can see how they were rammed suicide boat against Sri Lanka Navy vessels. My aim. The unmanned waterborne vehicle was primarily designed to mislead the LTTE boats during sea battles. A secondary purpose of UWV was to use it as the first line of battle and avoid human casualties. The main objective of this research project was to stop LTTE suicide attacks by operating and triggering this UWV with a safe distance and minimum damage to the SLN during sea confrontations. Design features, material selection. Fiberglass was chosen to make this aeroboat due to its low cost, lightweight, minimal elongations, and availability of experts and infrastructure facilities at SLN. Design of hull. Types of hull was decided after conducting number of trials, utilizing an 18-foot dinghy, 16-foot aeroboat, and 18-foot aeroboat with 200 kg payloads. Eventually, a planing hull was selected for this UWV because ability to push through the water and skim across the water's surface. According to the preliminary design, construction of 18-foot aeroboat was begun with the fabrication of hull. The length of this arrowboat is restricted to 18 foot and maximum breadth is curtailed to 5 feet and 3 inches. The height 2 foot and 7 inch with both sides angle out. Propulsion system. Short tail 2-stroke 75 HP outboard motor was chosen as a propulsion system for this arrowboat due to easy handling in shallow water. To achieve maximum speed, destroy the enemy target without surprise. Selection of correct propeller. The propeller size is expressed with two numbers, diameter and pitch, with diameter always stated first. The diameter is 2 times the distance from the center of the hub to the tip of any blade. Smaller prop diameter generally go with the small engines or with fast high-performing boats. Therefore, in this contest, smaller size propeller was fixed with 75 HP OBM as per guidelines of Yamaha manufacturer to meet SLN requirements. In addition, rake is the degree that blades slant forward or backward to the hub. Rake can affect how water flows through the propeller, which can make a difference regarding boat performance. Trim angle. Trim angle is very important aspect, fixing an OBM to the arrowboat and leads to maintaining the stability of the vessel and the speed. The correct trim angle indicated in middle of this slide. Control system. The steering system was developed utilizing from trim pump, and both port and starboard could be achieved maximum up to 30 degrees without harm to the stability of the UWV. Similarly, the speed control mechanism was incorporated with another trim pump and hydraulically controlled the acceleration and retardation during the experiment. The trim pump was powered by 24 DC and ensured to keep the batteries fully charged throughout. A steering system was very special in this UWV and hydraulically operated with the utilization of additional trim pump that was actuated by VHF signals and associated with fluid communication through the hydraulic cylinder that connected to the OBM. Then the prototype model had both steering as well as the throttle and was remotely controlled through a VHF link base on a handheld VHF communication sets. The control was exercised by pressing the PTT or the power transmitting toggle switch, and the quantum of control signal was determined by the duration for which the PTT was pressed. For differentiating between different types of command, different channels of the communication set were used. It may be pertinent to mention that the remote control circuit had been exclusively developed for this requirement and was quite different from other normal remote control systems. Test procedure. The UW was fixed with 120 kg of high explosive and amalgamated with the trigger mechanism, carry out explosion by VHF communications. An operator was on board another arrowboat at set, selected the target as an abandoned merchant vessel called the Farah 3, which was grounded at LTTE control area at Padumatalan. Subsequently, the operator has identified distance to the target from the operating platform by radar and prepared the UW for the assigned task. Then the UW was operated at speed of 40 knots at sea state 1 to 2 and reached the target within 5 minutes, carried out the task by ramming. This complete operation was observed by the Unmanned Aerial Vehicle, UAV, and recorded all the events were to make further improvements of UWV. Comparison of power versus speed. Generally, the y-axis is power, the x-axis is speed. While we are increasing the power and we are gaining the speed, what happens? The boats generally float support only buoyant at rest and very low speeds. As the speed increases, hull capable of planing makes a sharp transition to lifting surface while plowing up the bow wave. As the speed increases, further boat planes, and at a high enough speed, buoyancy becomes negligible. Hydrodynamic lift carries the weight. In here also, it's showing that the resistance versus speed. While we are increasing the speed, it goes up to 16 knots, suddenly come down, and again incline. That shows the hydrodynamic lift. Conclusion. LTT suicide boat launching was dramatically reduced during that time. And we can use this remote control boat for potent and can be used for a variety of tasks ranging from begin use as a target boat to offensive platform. Thank you.
Thank you very much, sir. Good morning. I'm Lieutenant Commander Eric Fernando, present here to deliver the technical paper on inductively coupled plasma optical emission spectrometer in effective condition-based maintenance engineering plan. So the authors, Commander Milinda Dasanayaka and myself. The sequence of my presentation is as shown in the screen. As engineers, we use various types of real-time condition monitoring equipments in order to decide the real maintenance requirements. So the inductively coupled plasma optical emission spectrometer, which is called as ICP-OES, is used by Sri Lanka Navy to determine the wear elements presence of the lubricant samples, basically the used lubricant samples in Sri Lankan naval ships and craft machinery. This will identify and quantify the element presence and the wear patterns of the machineries. So basically, moving into the operating principle, a plasma in gas, in this case, we use the argon gas. In here, the elements in the form of atoms are introduced into the plasma, and a proportion of these atoms will become ionized within the plasma. When atom or the ion excited within the plasma, its electrons jump from a lower to higher energy level. So we know that upon relaxation of these electrons to their initial ground state, there will be some amount of energy is emitted in the form of photons. So these emitted photons possesses a wavelength that are characteristics of their respective elements. But one element can have multiple electron excitation and the relaxation. So because of that, they may have various wavelengths with multiple characteristics. So it is the duty of the analyst to select the most suitable wavelength which will not interfere with any of the elements which we are going to test in our oil samples. So this process will finally formulate safety margins for the machinery fitted on board, and also it will help us to predict the unforeseen failures. So the sampling is the main important key process in this element analysis. So the objective of sampling is to obtain a test sample which represent the entire quantity of our lubricant oil system, because we have the some capacity is somewhere around 1,400 liters. So we have to make sure that we are taking a correct sampling as per the ASTM 5185 sampling test method. So in this ASTM standard, they have given element with respective wavelengths. So in our laboratory, we are basically more focused on these 7 elements which are which you can see in this table. So these wear element presence will be tested in our laboratory, and there are some wavelengths given as the standard test method. So initially in the Qtegra software, the software which is using for this ICP, in the software, the analysts have to check the interference between the elements. So you can see here, this is example which I have taken, that this in yellow color you can see the ferrous element, the wavelength is 252.851. This wavelength is interfered with the vanadium and antimony and some other elements. So, but in our case, this vanadium and antimony is not interfered because we are not going to test this vanadium and antimony, because we, as I shown you earlier, we are going to test only 7 elements. So this can be considered as normal, since none of these elements are going to measure in our analysis. But in case, instead of this vanadium or antimony, if we can see copper or silicon, some other element which we are going to test, so we should not select that wavelength. We can move into another wavelength in order to have a better results. So the second most important thing is the calibration, because we have to always make a linear range of the instrument. So in order to have a calibration prior every analysis, we have to do a calibration. So we are introducing 3 specimens of oil analysis standards, where we know the standard concentration of that particular sample is 1000 ppm. So we have to prepare these 3 samples in order to have a 3-point calibration. For that, we have used this C1 V1 is equal to C2 V2 formula. By using that, we have prepared 3 samples, and then during the calibration, this is an example of the calibration curve of the aluminium element. So you can see this 3-point calibration. We have to maintain the linearity closer to 1. If this R square value is closer to 1, it means that your calibration is perfect. And in other hand, we have to always think about of this LOD value, which is called as the limit of detection. If the limit of detection value is greater than the value which we are going, the results which we are getting for the aluminum element concentration, then those results should not be considered, and we have to introduce another sample in order to have a better results. So the testing frequency, we have given oil analysis schedule for all SLN fleet machineries and the gearboxes, shore-based generators. So we are, as I mentioned you earlier, we are using the ASTM D5185 standard as a standard test method. So moving into the study, this study was done for 16-cylinder V-type 2 reciprocating engines fitted on board one of the SLN major vessel, and these engines have clocked around 40,000 operating hours, where we can say that the initial OEM recommended maintenance schedule is over now. Now it is in condition-based monitoring stage. So we have focused our study on these 7 wear elements. At the initial stage of our initial baseline data recording, we have not observed any abnormality. But at one stage, we have seen the results of the port main engine and the starboard main engines like this. You can see the graphs. You can see that in starboard main engine, the copper element concentration, you can see this copper element concentration values, and the ferrous element concentration values are always lower. All element concentrations are lower to 25 ppm margin. So, but if you consider about the starboard main engine, we have seen that the ferrous and copper element presence is above the 25 ppm margin, where we can see that the copper element concentration value have been touched around 50 ppm as well. So here we have identified that there is an issue. So we recommended to change the existing oil, because we have standardized the safety limits for SLN main engines fitted on board major vessels, and we have given maximum permissible limits, as you can see in the screen. So you can see that the maximum permissible limit of the copper element can go up to 25 ppm, and ferrous can go up to 80, but none of the values have reached that level. But the copper, always we have seen that port main engine values have been increased. So because of that, we have recommended to change the oil and to flush the entire lubrication oil system. So after this, we have again tested the samples at every 250 hourly oil running hours intervals, and we have seen that the copper element concentration value always above 40 ppm margin, and it has reached up to 70 ppm value. So in order to have a better understanding, we have calculated the wear rate of the copper element concentration as well by using this formula, and we found that wear rate is also increasing with the running hours. So we recommended the repair authority to carry out an in-depth investigation to find out the root causes of the specific metal wear down. And with the available data, we had given them as the possible root causes like bearings, bushers, sleeves, bearing cages, coolant core tubes, the valve guides, valve strut washers as well. So during the inspection, the engine components were dismantled, and during the inspection, it was found that heavy metal wear down in number 9 bearing lower half, and also metal wear down in number 1 bearing upper half as well. So this has proven that because normally these bearings, the upper layer is copper, and when we because this material when we are testing with the OEM recommended test details, it is clearly indicates that the copper is the main source of these metal wear down. So after the breakdown repairs, we have again tested the samples in our laboratory, and we found that the copper element concentration values have been reduced up to the 25 ppm margin. But anyway, we can see that any of the machinery in the initial stage, during the initial first 50 hours operation, we can see some amount of element presence because of the initial metal wear down. So at the present stage, there is no any metal wear down observed in that particular machinery. So we can say that this has saved approx 20 million rupees by preventing the catastrophic failure. So moving into the conclusion, it is clearly we can see that the identification of developing malfunctions and also continuous machinery health monitoring will definitely prevent the catastrophic failures. And also these analysis records will give a guide for us to find out the root cause, and also to identify the environment, and also to identify the uneven mechanical loads such as stress, strains, and surface oil chemistry. In order to find the exact root causes, we are correlating all these test records with the vibration analysis results, the thermography results, the ultrasound results, and the non-destructive testing results. So it is confirmed that this type of analysis, this type of continuous monitoring of the wear down of the engines fitted in SLN major vessels will give us an opportunity to extend the life cycle of the machinery as well. So these are the references. So I would like to acknowledge Sri Lanka Navy for giving me this opportunity to study in this particular wear down analysis, and also the continuous support rendered from the Chemical and Process Engineering and the Mechanical Engineering Laboratory of University of Moratuwa. Thank you very much.
The fourth presentation is on cost-effective method to analyze lubricating oil. The presenting author is Commander TNA Rathnayake, and Commander Nuwan Aravinda Rathnayake, Marine Engineer of Sri Lankan Navy, and currently he is holding the appointment as Manager, Naval Boat Building Yard, and Manager Naval Design, Naval Architecture of Directorate of Naval Design. He graduated with BSc Engineering Honours in Marine Engineering from the Kottayal Defence University, and he possesses a Master's MSc in Material Science from the University of Moratuwa. Over to Commander Rathnayake for your presentation.
Thank you very much, sir. Good morning, ladies and gentlemen. This presentation is based upon good morning, ladies and gentlemen. This presentation is based upon effective method to analyze lubrication oil. So easy understand my presentation into topics that are flashed on the screen. Now, if you take the lubrication oil, the main purpose of this lubrication oil reduce the friction between the rubbing surfaces. And by analyzing oil, we can have an idea about the equipment that it works. It's like the blood in human body. Then identify whether the body is having some illnesses. When it comes to the analysis requirements of the available lubrication oil analysis method, it requires very sophisticated equipment, and also we have to take the lubrication oil sample and send it to the laboratory. Because of that, the time is very high, and also the cost involvement is also very high. And some of the methods specific environmental conditions. With that, the presentation is to design and fabricate a cost-effective lubrication oil analyzer to check the condition of the lubrication. If we talk about the functions of lubricating, I can say the lubrication oil lubricates and also cools the system, seal the system, and also it is very, very important that it reduces the maintenance cost of the equipment. So now the main properties of lubrication oil are flashed on the screen. The available lubrication oil analysis methods are physical, electrical, chemical, and optical techniques to analyze the lubrication oil. Since this is going to be a design lubrication oil analyzer, I have used these optical methods to finalize the analyzer. Let's we talk about why we required a cost-effective lubrication oil method. Basically, design and test the lubrication oil where the machine is located, and also specific environment condition would not require, and the reading we can get in a short. As I told you, the method is because of that I have selected this refractive index to get to analyze the lubrication oil, and refractive index is depending upon the quality of the lubrication oil, such as its viscosity, suspended particle density, also water content of the lubrication oil. The deviation of a light beam is depending upon the velocity of the light in a respect, and also the refractive index of that medium. The Snell's law describes the deviation of light as shown in the picture, the velocity of the light and the respective refractive index of the medium. This is the Snell's law, the equation. In accordance with when light ray passes through one medium to another, first medium is optically denser than the other one. The angle alpha, which is the incident, will be smaller than the angle beta, the refracted angle. If the incident angle is the critical angle of reflection, here it is alpha c, then the angle beta will be 90 degrees. When the incident angle of reflection, then the light beam cannot go through the other medium, it will reflect. This is called as the internal reflection. When a divergent beams passes through, it creates incident angle, smaller incident angles, and also the critical angle of reflection and reflection. Then we can, the internally reflected light into image as shown in this picture. The most important factor is that the critical angle of reflection is the refractive index of that particular medium. And all the lubrication oil refractive index is dependent upon the quality of the lubrication oil. And also when the critical, the brighter and the darker region of this image will change. That are used to fabricate this lubrication oil analyzer. A basic schematic lubrication oil analyzer as shown in screen, but the major components used is a camera and with a computer with accessories. For the testing of the design lubrication oil analyzer, be taken from a specific lubrication oil. That means we have to use on same analysis, because we are going to compare the fresh oil, the image oil samples. And also in this table, I have selected these lubrication. 3 times I have taken, because then the accuracy of the reading of this equipment will be high. For all these samples, I am going to take the internally reflected image to get the results. The lubrication oil Shell Gardenia 40, which is used in MTU 12V39 high-speed marine engines, are used to check the accuracy of this lubrication oil analyzer. And these engines are fitted in fast attack crafts, commonly known as RAS in Sri Lanka Navy. As this lubrication oil analyzer is fabricated using the prism and also a computer. I will show you a small video clip how this when we get the image to the computer. Now this is the image that they are getting. This is the first image without pouring a lubricant. And also when we put the new lubrication oil sample, this is the image that we can get. Put all these used lubrication oil samples with these intervals and take to the computer. After that, take the area of this brighter region. I have prepared a small program to calculate the area of this brighter region, and I will show you a small video clip of that also. We can feed the image to this program and get the area of the brighter region. Of course, we can control it. The operator can control the brighter region. After obtaining all these details, the results are shown. The main point we have to identify is that for the fresh area of the brighter region is higher, but for the other intervals, it's varying very more in small values. Now we have to check those results, whether those results are correct or wrong, because use the same oil by checking through these ASTM standards and also the viscosity comparator. Whether the results are accurate or not. Through the ASTM standard, I have taken the readings for 500 hours used oil samples, and for the properties were within acceptable limits. Likewise, as an analysis, STM standard N1 analysis, those are for 50 hours and 250 hours, 500 hours. The same used oil, those readings were within. And also I have checked these used oil samples through the, these are the readings that I have got. All these lubrication oil were within acceptable limits. By in those two available lubrication oil analysis methods results with the design lubrication oil, I can say that the readings that I have got from the design lubrication oil analysis. However, for further justification, I have forcibly diluted. That means the used lubrication oil sample was mixed with diesel and checked those samples oil analyzer. We can clearly identify that when the percentage of dilution in the brighter region area is also increasing. Through that, from that, I have checked a design equipment across testing Shelgarnia 40 lubrication oil, and also the obtained results were cross-examined with the available methods. Those are the viscosity comparator and also the ASTM standard methods. And also the equipment was further justified checking the diluted lubrication oil samples with through the analyzer, and the reading was accurate. It is recommended this design to monitor the degradation of lubrication oil without human involvement to equipment, and we can the results accurately and understand the condition of the equipment. These are some that I have gone through, and
Right. Thank you very much for the presentations. Okay, we can go to the question time and the discussion time. And I have a question to Commodore Dasanayaka with regard to your presentation on the unmanned operation boat operation. Now, this had been used for a military application during the humanitarian war. Now, after this, this is a very innovative design because it's an unmanned vessel. What are the civilian applications that you can, use this design with, maybe with slight modifications? Did you consider applying this to civilian applications thereafter?
Yes, of course, you are right. We can make use this application for the civilian use, but up today we kept it as a restricted one or secret one. Only this 2021 IRC we published this. After that we can think about it, sir.
Yes, because this is a very simple design when you look at it, with the outboard engine as well as hydraulically operated the actuating system, remotely operated, battery powered. So simple design. So this can be made use of for many civilian applications. It was one of my observations. Right. Thank you very much, Commodore Dasanayaka. Let us see questions from the audience. Okay, I will pose another question to Commodore Dasanayaka and the group with regard to the firefighting boat. Now, this is a smaller vessel with a engine-driven fire pump mounted on it, and you have done the stability calculations, mainly because of the shift of the center of gravity. But how about the dynamic stability when the water jet is in operation? Because we have the reactive forces coming from the water jet. Did you consider the dynamic stability of the vessel during operations?
Yes, sir. We have think about that dynamic stability also. Other than that, we have calculated the center of gravity, longitudinal center of gravity and the vertical center of gravity by using the NavCAD software, sir.
Right. Right. Good. Good.
Sir, I'm Lieutenant Governor Pereira. So my first question goes to Lieutenant Governor Chandimal. As in general, the general design of a normal firefighting boat is the firefighting pump. The main firefighting pump is coupled to the main engine. So in your design, it is like it is fixed in the forecaster. So is there any specific consideration that you have considered with in this design, or so what are the main design aspects, like moving into a separate design like that rather than going into a directly coupled firefighting pump?
Mainly, we have thought about the fires are occurred at the Fishery Harbours and it spreads to the other crafts also. Therefore, we have considered to hook and tow out the fire craft to the harbor bay and extinguish the fire. Therefore, we have considered to to install the fire pump in forecastle area. Then we can use our fire extinguishing method and we can turn it to 120 degrees in angle. Therefore, we considered in this aspect only we have considered. That's why we are not coupled with the main engine, and we have used the sea chest in the forecastle area, and we use only the OBMs, 4 number of OBMs to consider this situation.
Thank you, sir. And my second question goes to Lieutenant Governor Fernando. So you discussed about ASTM standards for marine diesel engines. So what my question is there any specific standards for naturally aspirated two-stroke engines, naturally aspirated diesel engines and turbocharged or supercharged two-stroke engines or petrol engines as well, like when you're taking into account like automobile engines or air compressors or such kind of applications? Is there any specific standards for that?
Thank you very much for your question. Actually, there are several standards, like there are several ASTM standards for each application. But in case if you want to test the lubricants, if it is automobile engine or whatever it is, the lubricants can be tested. Any of the lubricants, even if you want to test the blood or the water, any of the samples can be tested through the ICP. But there are several ASTM methods. But for the lubrication analysis, we can do any of the analysis by using this ASTM 5185 standard. But if you are talking about the automotive engines and all, like there are specific standards according to your requirement. Did I answer your question?
Any other questions?
I'm Kanchana Vijay Singh from Electrical Department. My question goes to Lieutenant Commander Fernando regarding this lubricant quality testing. So, according to my knowledge, the white light, it contains different frequencies. So then in this total internal reflection, so the refractive, the critical angles differ from frequency to frequency. So why you didn't select one color or like yellow or red or like that goes for white? Is there any reason? And there's another one. As I know, absorption spectrums are used to testing the quality of lubricant, but is there any comparative advantage of using refractive index other than absorption spectrum for this quality measures? Thank you.
So thank you very much for your questions. For answering your first question, basically, actually, this method is given. I mean, actually, we are using the ICP OES. The equipment itself is having this theory. So, I mean, like, I have not selected only one particular aspect because actually in this ICP OES, basically we use as a quantitative measurement by using the optical emission from the excited atoms to determine the light concentrations. It is not me who have selected only one, the entire IR spectrum. So
No, actually not IR spectrum. I am requesting. I mean, I'm incurring the visible light because we are using light, no, and then it's 100% clear
so
that
actually,
emission spectrum is fine. My
so this
problem is
not
now you are not getting the emission spectrum. You are getting the refractive index. That means there's a reflection. Okay, so it's the two different things. So that's why I want to clear it. That's why.
Basically, actually, we are like in the plasma itself, it is ignited into 9000 Kelvin into the 10,000 Kelvin range. So in that, it is the machine itself will measure these limitations.
Okay.
Any other questions or comments?
Thank you very much.
Now, these fishing harbors, we know that the fishing vessels are, anchored or tied up, very close to each other, or sometimes they are just dragged to a shore and highly concentrated area. How often these fires happen in these fishing harbors? Is it due to natural or some mistakes, or is it due to arson attacks, or what kind of fires? What is the cause of origin of these fires?
The mainly, sir, they are using petrols for the this fiberglass dinghies, this kind of GRP materials they are using, sir.
Right.
Therefore, due to some of their negligence and all the things of the fishermen, the fires has occurred. And finally, this fire has, due to the windy condition, it has spread to the crafts also, sir.
Right.
That's the main reason, the fishermen's negligence, and they are using petrols in this situation.
Right. And the vessel that you have designed is capable of pulling the boat which is on fire and then extinguishing it after taking it out from there, or even without pulling it out, it can spray the water.
Yes, sir, it has the capability to hook it out and we extinguish the fire in the harbor periphery.
Right. Any further comments from the audience or from the presenters? Okay, I think we had a very good, lively presentations, 4 presentations in the second session, and also a lively discussion. The research objectives of the Kottalaru Defence University, we can see it is moving in the right direction, and this annual research conference has brought many aspects into light, and also good participation from the academia as well as from the industry. And this is, as far as marine engineering is concerned, I think this is the premier conference that we have in Sri Lanka. And I wish to thank the coordinators, the Vice Chancellor, and all the organizers of the research conference and these engineering technical sessions by Commodore Dasanayaka and the group here. And so with that, we will conclude the second session, and let us move on to the next item in the agenda.
Thank you, sir. Ladies and gentlemen, now as we have come to the end of the marine engineering session, I cordially invite the Dean of the Faculty of Engineering, retired Captain S.U. Dampage, to award the certificates to the presenters. Commodore MCP Dissanayake. Lieutenant Commander PMKC Chandimal. Thank you, sir. On behalf of the organizing committee, I would like to thank Dr. TA Piyasiri for chairing today's session and for spending his valuable time to make this event a success. With this, we would like to conclude this session. Thank you very much.
Thank you.